eat any, and it's the second time you eat half as much as you.
Okay, this one says that Becca eats 2 M&Ms every time I eat 1. This one says that I eat 1 M&M every time Becca eats 2. What's the difference between those two? The information given in those cases.
It's just in a different order.
It's just in a different order. There's no difference.
Exact same thing.
Yeah, these two lines actually, yes, these two lines actually convey the exact same information.
So you're saying that these two parabolas are exactly the same, just in different ways?
No. And here's why.
That was actually really smart.
No, that was great actually, but it's okay.
Well, that's what you just said for this one.
All right, here's what I'm going to say here.
The lines and parabolas are completely different.
Okay, check this out. These are inverse functions. These are inverse functions.
Nice use of N.
Thank you. These are inverse functions. They tell the same information. The x and y's are switched. Okay, go into more details on that in a second. Follow me over here, Eliza. These are inverse relationships.
What's the difference?
This is a function, right? Mimi?
Fun.
This top parabola?
Yeah.
It's a function. Is this sideways parabola a function?
No.
So I can't call them inverse functions because when I inverted this parabola, the result was not a function. When I inverted my line, the result was a function.
Are you saying because these pass the line test and the other ones do, but the one on the bottom doesn't?
Perfect. Exactly. Yes. Because once I switched the x and y, I got something that failed the vertical line test. I can't call these inverse functions.
Even though they make, would they convey the same information? If we get rid of the, okay.
Sure. If you switch the x and y, yes. Or if we just all decided tomorrow to make the
It's kind of like how if you have x equals y, but you make it y equals x, it's the exact same thing.
That's exact. Hold that thought. We'll get back to that. Okay. So now, follow me back over here now, Eliza. So that's the difference between an inverse function and an inverse relationship. Now we're going to get to the ugly math parts.
Wait, this wasn't the ugly part?
No. This was the pretty nice frolicking in the fields part. Now we're getting down into the low, cold, dark valley of death part.
You ran out of creative.
I did completely run out of creative things. Okay, so let's see. All functions can be inverted. Okay, all functions can be inverted. To invert is to switch the x and y. To invert is to switch the x and y. Okay, you can always switch the x and y. Sometimes the result is a function. Sometimes the result is a function, sometimes not. If it is, the result is
Can't see.
f negative 1x. That's the notation we use. Make a quick comment on notation before I go on. I hate this notation.
Then don't write it.
I hate it too.
Everyone uses it. We're stuck with it. The 3 most commonly and easily confused words in math are opposite, reciprocal, and invert.
Oh yes, those are so cool.
They mean 3 completely different things. What does opposite mean?
Opposite, as in like I'm opposite from you.
The exact difference.
Mathematically, does anyone know what opposite means?
Is it like positive versus negative?
Yes, Eliza, perfect. Opposite only refers to plus or minus.
It definitely meant that.
Yes. Reciprocal.
Flip it. Like flip it.
Reciprocal. What does reciprocal mean?
Fractions.
Flip
Fractions,
the-
flip it.
You flip them.
When you said reverse, I was afraid you were going to be like, it's the opposite. It's like an inversion. Now, a reciprocal actually has a very specific, it is, you guys are right about what it does to a fraction. It has a very specific meaning. A reciprocal, when a number is multiplied by its reciprocal, the result is positive 1. That's the actual definition of reciprocals. Two numbers that multiply together to get positive 1. What's the fastest way to find a number that can multiply by another number to get positive 1? Make it a fraction and flip it. That's the actual definition.
2 over 1 times
1 over 2 will always get you 1. Negative 5/3 times negative 3/5 will get you positive 1. That's the actual definition of a reciprocal.
So you have opposite, reciprocal, and which was the last one?
Inverse, which is, I'm just going to write switch x and y, but it's actually switch the axes, switch the dependent and independent variable. Because it doesn't matter what letters we're using or what we're talking about. It's switching the two axes.
So the Becca, Mr. Beliveau thing, those two were inverse of each other.
They were inverse functions of each other. They weren't just inverses of each other, because their lines are always non-vertical lines are always functions. These three words are always mixed up. They mean three very different things, but I don't blame you guys for mixing them up. One, they're all kind of switches in a way, so they kind of seem like reverses.
They're all the opposite of each other?
God, they sort of seem that way. The other reason I don't blame you guys for mixing this up is this notation. Okay?
-1.
This -1 here. Here, it means inverse. If you guys can remember back to last fall on matrices, this meant inverse.
That's so long ago.
What's 5 to the -1? What does this tell us to do?
Take a negative.
No, my God, no. Negative exponent.
Doesn't mean
What did we just do?
Didn't you just say inverse?
Oh, right.
It's 1 over 5 to the first.
It's 1 over 5 to the first. What's the relationship between 5 and 1 over 5?
Reciprocal.
Reciprocal. So this notation here, this -1 up here in a superscript, here it means inverse. On a matrix on your calculator, it means inverse. On a number, it means reciprocal. I hate this. I really hate this. You're stuck with it. I'm sorry.
Then why are you teaching it?
Okay, this -1 here, if you see it on a function, Artur, it means inverse. Switch the x and y. If you see it on a matrix, it also means inverse, which is a little different. If you see this -1 on a number, it means reciprocal. So we use the -1 to refer to reciprocals and inverses.
This is annoying.
I agree.
Yeah.
It all comes down to an argument. I think, if I read one thing, it came down to an argument between René Descartes and this guy named Viète, another French mathematician. And they couldn't agree,
Does
so
all
chose...
nouns come from
Viète.
Fran-
Oh my god,
France?
I'm so interested. Please tell me more.
Well, okay, you know, Viète, actually...
Nice job, Sarah.
Actually, I'll tell you one thing. They actually had math contests back then to see who could get... It was, honestly, it was like a math version of American Idol in Europe back then. They'd have these contests and people would come watch.
It's broadcast on national television too?
Yes, because they'd invented satellite broadcast television
Well,
in
they have math competitions
1599.
nowadays.
Yeah, but they were bigger back then. And Viète is a guy who, honest to God, was once in front of the king in court, basically in a job interview. He was hit with, find this, you know how you guys were finding the intercepts of polynomials a week or two ago?
Yep.
Okay, he was hit with one that began y equals x to the 45th, and went on and had 44 terms after it.
How do